Good day to all of you. Now we are going to start with the chapter Congruence of Triangles. So I'll just give you a brief introduction about the chapter. So we are going to deal with congruent figures. Congruent figures are any geometrical figures having exactly the same shape and size are known as the congruent figures. So now we are going to learn about the congruent triangles here. So two triangles will be congruent if and only if their corresponding sides and angles are equal. So that means they are exactly identical. For example, if you have a triangle ABC and PQR, now angle A will be equal to angle P, and then angle B will be equal to angle Q, and angle C will be equal to angle R. Also, the three angles and the three sides also should be exactly equal in length. So AB is equal to PQ, and BC is equal to QR, and AC is equal to PR. Then we say the two triangles are congruent. To write congruent, this is the symbol, one equal to and then one S, like this. So then we say triangle ABC is congruent to triangle PQR. Now when you are writing the congruence, you should be very clear about how you write this sequence. So in the first triangle, when you are taking ABC, now here you are taking A, B and C. So what is corresponding to AB is PQ. Then we have taken BC. So corresponding to BC is QR. So the same sequence you have to write, like if you start with ABC, then you should write PQR. In case you are starting with ACB, that is this one, then this, then again similarly corresponding to AC is PR and corresponding to BC is QR. So you should start with PRQ. If you don't write the sequence properly, then you will not get the corresponding parts. So suppose if triangle ABC is congruent to triangle QPR, then angle A will be equal to angle Q, angle B will be equal to angle P, and angle C will be equal to angle R, and AB, this AB will be equal to QP. Similarly, PC will be equal to PR, BC will be equal to PR, and AC will be equal to QR. We say this as corresponding parts of congruent triangles. In short, we write it as CPCT. Now that means now the six parts, that is the three sides and the three angles, should be exactly equal to each other. That is what is called the congruent of the two triangles are congruent. Now we have certain criteria. Suppose we can say the two triangles are congruent even if you don't have the six parts. If we have three of them, sides and two sides and one angle, or one angle, two angles and one side, similarly we can say the triangles are congruent. So the first one that we are going to see is SAS criteria. So SAS criteria, as the word says, it is two sides and one angle in between the two sides. So if two triangles have two sides and the included angle of the first triangle, so the two sides, suppose we are taking AB and BC, AB is equal to XY, BC equal to YZ, and the included angle means the angle in between the two sides that we are considering. So we have considered AB and BC, so the angle in between the two sides are B, and similarly for the triangle XYZ, it is angle Y. Suppose we have these datas, that is AB equal to XY, BC equal to YZ and the angle in between the B equal to Y. If these three data are available, we can say the triangle ABC. Again the same sequence we have to take. So ABC, if I am starting, then XY, triangle XYZ. Automatically the other three things, that is angle A. Angle A will be equal to angle X. Here see, this one and this. And angle C will be equal to angle Z. And similarly, AB and XY, AB equal to XY, BC equal to YZ, we know. We can write AC is equal to XZ. This one, AC is equal to XZ. So this is what we say as corresponding parts of congruent triangles. So this is how you should use the SAS criteria. Similarly, now we have ASA criteria. Here, as the name suggests, the side is in between the two angles. So suppose ABC and PQR. Now we have two angles. Suppose we have A is congruent, A is equal to P, you have A equal to P, then B is equal to Q, angle B equal to Q, and the side should be in between the two angles, that is AB is equal to PQ. So then you can say, so this should come, I will rewrite this. I will write angle B equal to angle Q and AB is equal to PQ. So this is A, this is S and A. So ASA criteria, we can say triangle ABC is congruent to triangle PQR. So the other parts, angle C will be equal to angle R, then BC will be equal to QR, and then AC equal to PR. We can conclude from that. Now going to the next criteria, that is now AAS, that is two angles and the side next to that. So suppose we have angle P equal to angle D, angle P equal to angle D, then angle Q equal to angle E, these two angles, and the side next to that, it should not be included. If it is PQ, then it becomes ASA. Now it is AAS, so it can be QR equal to EF, or we can also have angle P equal to angle D, angle Q equal to angle E, or PR equal to DF. After the two angles, you should have the side. So in both cases, you can say the triangles are congruent. So writing the congruence PQR will be congruent to triangle DEF using AAS criteria. Now comes the SSS criteria. Here no angle is there, all the three sides are equal to corresponding sides are equal, then you can say the triangles are congruent, and automatically the three angles will be congruent, will be equal. So AB is equal to PQ, BC is equal to QR, and AC is equal to PR. AB equal to PQ, BC equal to QR, and AC equal to PR. Therefore, triangle ABC is congruent to triangle PQR. So, using SSS criteria. Now, the last one is the RHS criteria. This is two right angle triangles. That means now angle Q and angle E are equal and they are 90 degrees. So it is a right triangle and the hypotenuse has to be equal. For RHS criteria, you should have right angle, that is R, then hypotenuse h. So, you have angle Q equal to angle E equal to 90 degrees, that is R, then PR equal to DF, that is hypotenuse, then any of the other one side. So, it can be PQ equal to DE or QR equal to EF. So, then we can say the triangle, so triangle PQR congruent to triangle DEF. So, that is all the criteria. So, we have the first one is SAS, then we have ASA, then AAS, SSS, and the last one RHS. Now, we have another type that you will be learning in your 10th standard, that is similar triangles. In similar triangles, all the angles are equal, but the sides are not equal. If the sides become equal, then it becomes congruent. Now, for similar triangle, see the size of the two triangles, ABC is big and PQR is small. So, the ratio of the sides like AB by PQ, this AB by PQ, then this by this by this, and this are the ratio of the sides are proportional. So, such triangles are called similar triangles. So, in the next I will come up with problems in my next video. So, till then try to understand these criteria and see you back soon.